Okay, welcome back to the online version of MA242. As you can hear, the Diet Coke is cracked and we're ready to get started. And what I want to do, since it's been a little while since the break, is just review some real basic concepts about infinite series that we covered before we left. So, just to start off with, series is math speak for sum. And the way that we write sums in mathematics is to use a kind of compact notation that we call summation notation. And the key to being able to do this is to take the things that we want to add up and express them as elements of a sequence. So if I wanted to add 1 plus 2 plus 4 plus 8 plus 16, I'd realize that I could write these as elements of the sequence 2 to the nth. So obviously 1 being 2 to the 0, 2 being 2 to the first, 4 being 2 squared, and so on and so on. And if I have a sum where I can express the terms in that sum as elements of a sequence, then I can go ahead and use this summation notation. And so when we're using summation notation, for example, we use this symbol sigma. So sigma is just a set of instructions. It just says, okay, I want you to sum a bunch of terms. So this is sigma, and it means sum. And what do we sum? Well, we sum whatever's to the right-hand side of it. So this is called the summand right here. These are the elements. This is the sequence that I want to sum up. And you notice that a sequence has an infinite number of terms, right? It's just an ordered list that's infinite. So we have to tell this set of instructions where to start. It's kind of like a computer command, right? So this n is called the index. Okay. It stands for the place of the terms in the sequence. So this is n equal to 0, n equal to 1, and so on. So this is called the index. And we have to tell the sum then what should be our starting index. So sometimes this is called the lower index or the starting index. It tells us the first term in the sequence where we want to start the sum. And of course, this is called the upper index. And it tells us the last term in the sequence that we want to sum. And so in general, if we had a series, this would be some general form. I have some general sequence, a sub n, and I'd tell it, okay, to start at the nth naught place, wherever that is, and go up to the capital nth place. And it's worthwhile noting, and you might have seen this or kind of recognize this yourself, that sums are like the discrete version of integrals. And in fact, we're going to explore this analogy when we talk about the integral test for series convergence later on. Notice that sigma is like the integral. An integral is kind of like a sum. We're summing up an infinitesimal pieces of area, right? The summand is like the integrand, the thing that we're summing up. The lower index, and n is like x, by the way, okay? The index kind of behaves like a variable. And the lower index is kind of like the lower limit of integration, and the upper index is kind of like the upper limit of integration. And so series themselves are relatively simple once you figure out how to represent the terms in this the series in terms of sequences. But we want to move on and now talk about infinite series, and this is what we're going to be concerned about really for the rest of the semester. And so infinite series just means infinite sum, okay? And so this would be the general form. I'd have some starting index, and I would just keep on incrementing it going out to infinity, okay? And if you don't mind, I'm going to write this in a kind of generic way. This is going to be implied to be an infinite series. The reason why is this is kind of cumbersome to write. Okay, the n sub naught, and it's easy to confuse it with the n. Okay, this is some specific but unspecified number. This is an actual number, but I'm not specifying what it is. It can be anything. And rather than write that, I'm just going to write n, and this is going to be implied to be an infinite series. Okay. And the difference between these two is vast, because whenever you have a finite sum, it's always guaranteed to exist. Its value will always exist. But the problem with infinite series is that the sum of these infinite terms may not exist. And we're going to talk in the next video about what this semi-cryptic statement means, what it means for an infinite series not to exist.